Automatic fire sprinklers, obstructions and impediments.
Any obstructions in excess of 4 feet in width must be protected by an upright sprinkler. This is because the obstruction presented by the 4-foot dimension has been tested and determined to be a critical factor. So when we have HVAC ducts and the like that obstruct the spray pattern from the sprinkler above, this would necessitate the installation of a sprinkler below that obstruction. In some instances, for construction restraints, such as HVAC contractors, they'll bank a series of ducts that are less than 4 feet in width together that may create an aggregate obstruction in excess of 4 feet in width. In these situations, the upright sprinklers will be required. Such modifications to the HVAC duct layout needs to be submitted to DSA for review and approval. Here's a picture with multiple conduits. As we can see, the sprinkler piping up above. Other than the exposed box that doesn't have a cover on it, what else is wrong? The sprinkler spray pattern is impeded by the multiple conduits. The proximity of these multiple conduits to each other in relation to the sprinkler deflector creates the impediment to the sprinkler spray pattern. So, not all obstructions are going to be clear and solid. PI needs to be aware of other conditions that may obstruct the spray pattern. Here's another picture. Note that the upright sprinkler is too close to the underside of the duct, such that it's actually encroaching into the insulation up above. There must be a 1-inch minimum clearance above that sprinkler. Here's another sprinkler installation problem. The sprinkler itself has been concealed by the duct insulation material. In this configuration, the insulation is going to prevent proper operation of the sprinkler head. As part of the sprinkler system, there are components that are interrelated to fire alarm systems. The check alarm valve assembly and water flow indicators for proper connection according to the DSA approved ironing. The alarm check valve and the water flow must transmit a signal, supervisory signal, to the fire alarm control panel. Also want to check the dry pipe systems when provided for proper installation according to the plans. Dry pipe systems have other signals such as high and low pressure if there's a compressor on the system, could be valve opening, supervisory switches, or other tamper switches that need to be connected to the fire alarm system. So we want to observe that all of the test alarm signals are received at the control panel in the appropriate time. Need to verify that the correct size orifice is installed in the alarm test device. In those cases where the inspector's test assembly is utilizing a sprinkler head as the control discharge mechanism, that requires a minimum 1/2 inch orifice sprinkler head to be installed. And that test connection terminates with an appropriate K factor. So we're going to have our 1/2 inch sprinkler orifice with a K5.6 factor at the end of that inspector's test. The other option would be for the contractor to install a combination main drain and test piece of equipment right at the sprinkler riser itself. This would be permitted. Let's look at NFPA 13, section 8.17.4.2.1, which states a trip test connection or manifold not less than 1 inch in diameter piping terminating in a smooth bore corrosion-resistant orifice to provide a flow equivalent to 1 sprinkler of a type installed on the particular system shall be installed.
Automatic fire sprinklers. Testing and documentation.
Here's an example of that figure 25.1 and where the signatures are required. There is a complete copy of the material test certificate located in the resource section. And finally, we want to make sure that the spare sprinkler cabinet has been provided and that the appropriate sprinklers are contained, and that the contractor has provided the school district with copies of Title 19, Chapter 5, Fire Extinguishing Systems.